You're watching a tutorial on controlling LCDs with an Arduino. If you've ever worked with an Arduino, or any other microcontroller for that matter, you would have come across the standard alphanumeric LCD display. These things come in a variety of shapes, sizes, and colors, and are great for displaying data such as readings or debugging information. In this video, I'm going to show you how these LCDs work and how to control them with an Arduino. Also, I'm going to go through how to access all of the features of the device through the Arduino Liquid Crystal library, and, well, you'll be surprised with what you can do. The first thing I'm going to talk about is the pinout of an LCD. The LCD has 16 pins as follows. Let's zoom in to take a closer look. I'll start with the basics. Pin 1 or VSS is just ground. Pin 2 or VDD is 5 volts supply. The VO pin is the output from your potentiometer wiper pin to adjust contrast. Pin 4 is called RS. It stands for register select, and this pin lets you choose between sending commands or sending characters to the LCD. I'll give you an example here. A command would be something like set the cursor to a certain position, or clear the display, or even turn off the display. A character is just a text symbol that you want to display. When the RS pin is given 0 volts or ground, you send it a command, and when you give it 5 volts, you send data such as a character. I'm printing text, clearing the display, printing more text, setting the cursor, printing some symbols, setting the cursor somewhere else, printing more text, and clearing the display. After the RS pin comes the RW pin. This stands for read-write, and it lets you select between giving an instruction to the LCD, like clearing the screen or sending data, and reading information from the LCD. What information is there to read from the LCD, you may ask? Well, the answer is actually not much. One instance of this that I can think of is to check for something known as a busy flag. Basically, when the LCD is processing information and executing its instructions, it will make pin D7 go high, to indicate that it's in the middle of doing something. When it's free and ready to accept new instructions, that pin will go low. However, you can't check this unless the LCD is in read mode, and for that, you will need to make the RW pin go high. However, the Arduino Liquid Crystal library is quite clever in the way it handles things. You can tie the RW pin straight to ground, which permanently puts the LCD in write mode and introduces a long enough delay for the LCD to become free. This is less efficient code, but it saves on a precious I/O pin, and you wouldn't notice the extra time taken anyway. Then comes the E or enable pin. You can think of this as sort of a light switch for the LCD. When you flash this pin high and then low again, the LCD can see the state of the other pins and execute the right command. Next, you'll see pins D0 all the way through to D7. This is an 8-bit parallel data port for the LCD. After setting the RS and RW pins, you would make this port equal the 8-bit value of the character or command that you want to send. For example, the value for the capital letter A is in binary 01000001, and the 8-bit value for the command clear screen is just 00000001. To check the values of commands, refer to the datasheet. I've put a link to download it in the description. To check the values of characters and symbols, just Google the American Standard Code for Information Interchange, or ASCII. Finally, the last two pins are the anode and cathode for the LED backlight. I'm going to give you a quick example of what goes on when you tell the LCD to do something. You don't really need to memorize this because the Liquid Crystal library takes care of most of it for you. Say I want to display the capital letter A. First, I would check if the LCD is busy. To do this, I would go into read mode so my RW pin would be high, and keep flashing the enable pin until the busy flag goes low. The busy flag is located on pin D7. When it goes low, I know that the LCD is ready to accept instructions. The first thing I might want to do is clear the display. The binary code for this command is 00000001. If you remember, to send a command the RS pin must be low, and to write to the LCD the RW pin has to be low as well. Then I would make the parallel data port on the LCD equal the binary code I want to send. Remember, D7 is the most significant or rightmost bit, and D0 is the least significant or leftmost bit. This is the reverse order of how the pins are arranged on the LCD. So anyway, I would write the binary code 00000001 to the LCD port. Finally, I would have to flash the enable pin on the LCD like flashing a light so the LCD can sort of see the data on the data port. Also, I would put a small delay after sending the command because it takes a little bit of time for the LCD to execute its commands. You can find the exact times on the HD44780 datasheet, but for clearing the screen, a delay of around 2 milliseconds is fine. Now that I've cleared the screen, I need to print the letter A, but first I need to wait until the LCD is no longer busy. Now that it's free, I can send the letter A to the LCD. Doing this is very similar to sending a command, only when sending data, the RS pin, which is the register select pin, needs to be high, and the read-write or RW pin would remain low. Then I would send the ASCII, the ASCII data code for a capital A, which happens to be, in binary, 01000001 to the data port. Then just like when sending a command, I would flash the enable pin for the LCD to see the data. The circuit that we're going to use is as follows. The RS pin is connected to pin 12 of the Arduino and the enable pin is connected to pin 11. The RW pin is connected straight to ground and pins D4 to D7 are connected to the Arduino pins 5 to 2. You notice that I haven't connected pins D2 to D0 to anything. This is because we're going to operate the LCD in something called 4-bit mode. This is when instead of sending the 8-bit character command value in one go, we send it in 2 half bytes or nibbles in a row. This just saves an I/O pins. Also, the potentiometer is about 10 kilo ohms and it adjusts the contrast of the display like this. So the first thing we're going to want to do is import the liquid crystal library. You can just go to Sketch and import library and just click the liquid crystal. Then we're going to create our LCD object and name it something like just LCD and type in the RS pin, the E pin, D4, D5, D6, and D7. Then we're just going to go to our setup section and initialize the LCD by typing in lcd.begin and the number of columns by the number of rows. So we're using a 16 by 2. And we're going to clear the LCD just in case there's something already printed. This is not really necessary, but it's a good habit to get into. And then we're just going to go to a loop. And let's try printing something. So we just do lcd.print and enclose whatever you want to print in double quotation marks. Like that. And we'll add some delays, so we'll cycle through a bunch of things so you can actually see what's happening. And now we're gonna try and set the cursor. So we're gonna clear the LCD and use the set cursor command, and you type in the row by the column, indexing from 0. Then we're just gonna go lcd.print and type in something like setting cursor. And we're gonna add another delay and do something else after that. So let's do that now. lcd.clear again, just to get rid of whatever's on the screen. And let's put in a blinking cursor. So we type in something, and this command is called lcd.blink, and it's pretty simple. We're just gonna add a small delay again, and let's get rid of the blinking cursor and create an underline cursor. So lcd.print underline cursor or uline cursor, and oh, we actually forgot to enclose that within double quotation marks. And lcd.cursor is the command to create an underline cursor. And we'll add a small delay. And then we're going to get rid of the cursor by typing lcd.clear. And this command is called lcd.nocursor. And we'll print the text first, and then type in lcd.nocursor with the C capital. And that should get rid of the cursor that's there. And we'll add a small delay. By the way, if you want to get rid of the blinking cursor, you just type in lcd.noblink. So we're going to clear it again, and let's let's turn off the display. So we'll type in no display.
And we'll add a small delay in there as well, just so you can actually see the text, and then we'll turn it off. So maybe a delay of, I don't know, 1 second. And we're just going to go lcd.no-display decapital. That's the symbol command to turn off the display. Remember, the text is still there, you just turned off the display. So we're going to actually print lcd.display on. And then we're going to turn on the display. So we'll create a small delay so you can see the display being off. And then we're going to turn on the display, and the text is magically going to be changed. Because even though the display is off, the LCD is still working. And we're going to add a small delay and repeat the loop all over again. And just some bugs we need to fix. We need to type in lcd.noblink before doing the lcd.print or before doing the lcd.cursor command. Otherwise we'll have two types of cursors going on at the same time. And we forgot to clear the display here as well. Before typing in the display on, we need to clear the display and then type in display on. So as you can see, it's doing exactly as we expected, setting the cursor, printing the display, putting a blinky cursor and an underlined cursor, and it should turn off the cursor after that. Yep, then turn off the display. And we actually forgot to clear the display one last time before starting the loop again, so you'll see what that looks like. Yeah, like that. If you think of each character on the LCD as a block of pixels rather than a unique symbol, then it's easy to see how the characters are formed. Each block is 5 pixels by 8 pixels, but the bottom row is usually left blank, to leave room for a cursor. LCDs like these, with the industry standard Hitachi controller inside, can support up to 8 different custom characters. So the first thing we're going to need to do is create an array of bytes. And since an LCD has 5 pixels by 7 pixels, the bytes are going to be 5 pixels long, and there are going to be 7 of them. I've just created enough space for an extra one, just in case. So 5 pixels. And I'm setting them all to 0 right now, but if you turn them to 1, then that pixel would turn on the LCD. So there should be just one more. And we've got the commas as well between each byte. Next thing we're going to have to do is use a command called lcd.createCar, and that should be, or actually we've got to name the byte, so let's call it something like custom car. Anyway, so we're going to use lcd.createCar, C capital, second C, and we're going to create a car character which has a number in the memory address, so we'll put it as 0 and use the byte array of custom car. And let's print some text just to say what we're doing. And then we have to use a command called lcd.write, and let's set the cursor first actually to the second row. So 0, 1, and then we're going to use lcd.write 0, and that's just the memory location in which that character, the custom character, is stored. And let's try compiling it and see if we get any errors. And oh, you'll notice that we get this weird error. I don't actually know what it means, but I found it goes away when you change the 0 to 1 for whatever reason. I'll try and look into it and let you know if I actually find out what's causing it, but that should be all. And let's compile. This takes a while on my computer, but let's hold on. And it seems to be working fine. There we go. And that's really all there is to creating custom characters. Just remember to change the 0s to 1s where you want a pixel to be displayed. So that's it for this video. I hope it helps, and thanks for watching.